Hello, so I'll be solving question A. The question is, write an equation for the line tangent to the graph of x at x equals 1/2. So, to solve this problem, we'll first need to find the slope of x at 1/2. So, the way we'll do that is we'll take the function f of x, take its derivative. That gives us f of x equals 24x squared. Then, we'll plug in 1/2 into that equation, and the outcome is 6. So that tells us the slope at x equals 1/2. Then, to find the tangent line, we use the tangent line equation. The tangent line equation is right here. It's y minus y1 equals m, which is the slope, times x minus x1. So, now that we have our variables, we have our x coordinates and our y coordinates and our slopes. This is 1/2, and this is 1, so we plug in for x, we plug in 1/2, and for y, we'll plug in 1 right here, and for m, we'll plug in 6. If we solve for y, we get to the answer y equals 6x minus 2, and that's the slope of the tangent line.
Now we will be doing problem B. So first we want to draw a picture of what the problem looks like. The lines to find the area of R, they intersect at point x equals 1/2, and here they intersect at x equals 0. So basically, we know that this function right here is g of x, and this function right here is f of x, and we can figure that out just by looking at the equations. So f of x equals 8x to the third, and g of x equals sine of pi x. So basically, the first step that we need to do is write the area. And so basically, to find the area, we take the top function and subtract it by the second function. So we will write r equals, and then we write integral from 0 to 1/2, which are the x values, and then we write big brackets g of x, which is this top function here, which means from here all the way down, so this, minus f of x, which is the bottom function, so minus this part right here, and that is going to give us the entire area of right here. So then basically we replace the g of x and f of x with the equations. So we write sine of pi x minus 8x cubed. So then what we have to do is take the derivative of each of these, which turns into negative 1 over pi cosine pi x, and this one turns to 2x to the 4th. So then we can rewrite this. Actually, we don't need to rewrite it. Draw the line from 1/2 to 0. Then we plug in 1/2 because we're looking for from 1/2 to 0. So basically, we plug in 1/2 to 1 over pi negative cosine pi x, and we find that that equals 0. And then we plug in 1/2 into the second half of the equation, and we find that that equals 0.125. So we have 0 minus 0.125 for the first part. Then we plug in 0, and we find that when we plug in 0 to both of these equations, we get 0. So we just have negative 0.125.
Okay, for problem C, our question is asking us, write but do not evaluate an integral expression for the volume of a solid draining when R is noted about the horizontal line y equals 1. Therefore, our axis of revolution is at y equals 1, and the formula for that would be volume equals pi r squared times height. Therefore, we move to writing our equation, which would be pi, and then including our limits, and then right here we do the r square part. We combine both fx and g of x, and then we do 1 minus f of x, and then we square it, this is this part, minus 1 minus g of x square times d of x. Therefore, this part would be the pi, And then right here we combine our r squared, which would be our radius, and then our height would be d of x. And then that would be our volume.
So some common mistakes made were in A, taking the antiderivative instead of the derivative while taking the slope. In B, forgetting to multiply x to the fourth by 2. And in C, forgetting to put pi at the beginning of the function and the wrong order of f of x and g of x. So scoring for A, +1 point for correct and correctly formatted answer, +1 point for correctly using tangent line equation, +1 point for proper derivative equation. For B, +1 point for integrand, +1 point for antiderivative, and +1 point for the answer. For C, +1 point for limits, +1 point for integrand, and +1 point for the final.